Before we continue with case 3, 4, and 5, let's look at the definition of one-sided limits. So here we have this expression. So what is the meaning of x approaching a negative? Negative here means that x approaches the value a from the left-hand side. So negative sign here means your x is approaching the value of a from the left-hand side only. Therefore, what is the meaning of x approaching a positive? It means x is approaching the value x equal to a from the right-hand side only. So let's look at some example. Here we have a graph of y or fx. From the graph above, for question A, we need to find the limit of fx as x approaches negative 3, negative. So here we can see we have negative sign here. So this means that x is approaching negative 3 from left-hand side. So x equal to negative 3 is here. So we only need from the left-hand side only. So don't look on the right-hand side. Just look on the left-hand side. Look at the graph that is the nearest to the x equal to negative 3 from the left-hand side. So the graph that is the nearest is this one. And you can see that when the graph approaches negative 3 from the left-hand side, the value of y is 1. So the final answer is 1. Next, we need to find the limit of fx as x approaches negative 1 plus. So plus here means x is approaching negative 1 from the right-hand side. So negative 1 is here and it is approaching from the right-hand side. So only look on the right-hand side of negative 1 only. Don't look at the left-hand side. So on the right-hand side, look at the graph that is nearest to negative 1. So it is actually not the nearest. It is exactly next to negative 1 on the right-hand side. So as you can see, there is no graph on the right-hand side of x equal to negative 1. There is no graph here. So this means that there is no answer for question B. And hence, you can just write down the limit of fx as x approaches negative 1 from the right-hand side does not exist. So let's look at question A again. X approaching negative 3 from the left-hand side. So on the left-hand side, look at the graph that is exactly on the left-hand side of negative 3. So the graph that is exactly next to negative 3 from the left-hand side is this one. So we have a graph on the left-hand side. But for question B, there is no graph on the right-hand side of negative 1. So that's why this limit does not exist. Let's continue with question C. Find the limit of fx as x approaches 3 from the right-hand side. So x equal to 3 is here. And on the right-hand side of x equal to 3, we have a graph, which is this one. So you can see that when this graph approaches x equal to 3, the value of y is 1. So here is equal to 1. So that is how you find one-sided limits. The next definition is existence of limit. If limit of fx as x approaching a from the left-hand side is the same as the limit of fx as x approaching a from the right-hand side, which is a value L or the value y equal to L, this means that the limit exists. Because the limit from the left-hand side and the limit from the right-hand side both approach the same value, which is y equal to L. And hence, you can make the conclusion the limit of fx as x approaches a is equal to L exists. So, from the first statement here, you can see that from left hand side and from the right hand side, it has the same value L. So, if both the limits are the same, you can make this conclusion or this statement. But this time, there's no need for you to write plus or minus anymore. If it doesn't have plus or minus, this means that as x approaches a from both sides, fx approaches L. So let's look at the example here. For question 1, we have this graph. So from this graph, find the limit of x approaching -1 fx. So x equal to -1 is here. So we need to consider whether this limit exists or not. So you need to consider from left hand side and right hand side. Let's start from the left hand side. So limit of fx as x approaching -1 minus. This is minus because this is from left hand side. So on the left hand side of x equal to -1, we have this graph here. And you can see that as x approaching -1 from the left hand side, this graph approach y equal to 1. So this is equal to 1. Now let's do the same from the right hand side. So write down the limit of fx as x approaching -1 plus. This is plus because we are approaching from the right hand side. So let's look at the right hand side of x equal to -1. There is no graph here. So this means that this limit does not exist. So you can write down does not exist, or you can also write is undefined. Both means the same thing. So I'm going to use does not exist. So now you need to compare the limit from the left hand side and the right hand side. From the left hand side, the limit is 1. But from the right hand side, there is no limit. And hence, both limits are not the same. So make the conclusion. The limit of fx as x approaching -1 from the left hand side is not the same as the limit of fx as x approaching -1 from the right hand side. So if they are not the same, does the limit exist? The answer is no. The limit of fx as x approaching -1 does not exist. So for the final conclusion here, do not write plus or minus next to -1 here. Just write it like this, and this means that the limit does not exist. For question B, we need to determine whether the limit of fx as x approaches 3 exists. So let's look at our graph. X equal to 3 is here. So we need to look from the left hand side and the right hand side. Let's start from the left hand side. From the left hand side, we can see that we have this graph. And as it approaches x equal to +3, the value of y is 1. So you can write down from the left hand side, the limit of x approaching 3 negative fx is equal to 1. This is negative because this is left hand side. Now let's do the same for the right hand side. From the right hand side, we can see that there is graph on the right hand side, which is this one. And as the graph approaches x equal to 3, the value of y is also 1. So you can write down, from the right hand side, the limit of fx as x approaching 3 positive is equal to 1. This is positive because this is from the right hand side. Now compare both limits. From the left hand side we have 1, and for the right hand side we also have 1. So we can see that both limits are equal. So we can make the conclusion, the limit of fx as x approaching -3 from the left hand side is equal to the limit of fx as x approaching -3 from the right hand side, and the value is 1. So if both limits are the same, does the limit exist? The answer is yes. The limit of fx as x approaching -3 is equal to 1 exists. For the final conclusion, there's no need for you to write plus or minus. Just write it like this. This means that the limits from the left hand side is the same as the limit from the right hand side. I'm so sorry, but it's supposed to be +3 in the conclusion, not -3. For question 2, we are given a piecewise function, and we need to find whether the limit of hx as x approaching -1 exists or not. So this means that you need to check the limit as x approaching -1 from the left hand side and x approaching -1 from the right hand side. And as you can see from hx here, we have two different functions when x approaches -1 from the left hand side and the right hand side. So it helps if you draw a number line to help you in order to see what kind of function that you need to use. So just imagine that you have the x-axis. Next, look at the values of x that we have. The only values of x that we have is -1, so put -1 in the middle. Let's do for the first function. As x more or equal to -1, so we're going to have a dense circle. And as it is more or equal to -1, it means it goes to the right hand side. And for this area, the function hx is 3x squared minus 1. Now let's do for the second row. As x is less than -1, so we're going to have an empty circle going to the left. The function of hx is √3 plus x. So this means that on this area here, we're going to use the function hx equal to √3 plus x. So now let's find the limits from the left hand side and the right hand side. From the left hand side, we're going to put negative sign. Be careful, our function now is hx. That's why this is also hx. So x approaching -1 from the left hand side is here. So from the left hand side of -1, the function that we need to use is √3 plus x. So change hx to become √3 plus x. So now just substitute x equal to -1 into x. So just substitute the value as per usual. There's no need for you to put negative sign into x. Just put -1 only. And the answer is √2. Next, for the right hand side, I'm going to put positive here. And our function is hx. So look at the right hand side only. Note that the function hx is 3x squared minus 1. So change hx to become 3x squared minus 1. So now just substitute x equal to -1 into x. And just like on the left hand side here, there's no need for you to put positive into x. Just write down 3 -1 squared minus 1. And the answer is 2. compare both limits. From the left hand side, it is square root 2, but from the right hand side, it is positive 2. So you can see that both limits are not equal. So we can make the conclusion, the limit of hx as x approaches -1 negative is not equal to the limit of hx as x approaches -1 positive. So if both limits are not the same, hence the limit of hx as x approaches -1 does not exist. Since left hand side is not equal to right hand side, that's why the limit does not exist. For question 3, we need to find the limit of this function fx when x approaches -2 from the left hand side. Just be careful here, you can see that we have an absolute function. So, define modulus x plus 2 first. Let's recall the meaning of modulus x plus 2. This is a piecewise function. So you're gonna take the one inside the bracket and you're gonna put it 4 times in the right hand side here. In the first row, put positive. Positive means that it is more or equal to 0. In the second row here, put a negative sign and you're gonna put less than 0 here. So now we just need to simplify this piecewise function. This part here stays the same. You only need to simplify this range of x here. This one will give you x more or equal to -2. And this one will give you x less than -2. So this is the definition of modulus x plus 2. Note that this is a piecewise function. So you're gonna draw the number line to be used as a guidance. Imagine that you have the x-axis. So look at the values of x that we have. We only have the value of -2, so I'm gonna put -2 in the middle. For the first row here, when x is more or equal to -2, the function is x plus 2. So modulus x plus 2 will become positive x plus 2. And for the second row here, when x is less than -2, the function is negative x plus 2. Therefore, modulus x plus 2 will become negative x plus 2. And now we can use this information from this number line in order to evaluate our question. So copy down our question. So we need x approaches -2 from the left hand side. At x equal to -2, from the left hand side, the graph is modulus x plus 2 equal to negative x plus 2. So we're going to change modulus x plus 2 to become negative x plus 2. And now we can simplify our function by cancelling out x plus 2. So we'll be left with negative x plus 3 only as the function. So substitute x equal to -2 into x. And the final answer is -1.